More than 1/4 of new job postings in the United States are in roles that analysts deem highly transformable by generative artificial intelligence, a share that moved from hypothesis to measurable reality in a single business cycle. Employers now post tasks that pair humans with large language models, automate help desks with synthetic agents, and route knowledge work through co-pilots embedded in everyday software. The headline is no longer experimentation, it is integration at scale. Indeed's most recent AI at Work analysis estimates that roughly 1/4 of postings are highly exposed to generative systems, while a much larger share is moderately exposed as adoption spreads beyond technology into finance, healthcare administration, logistics, and government. The clearest corporate case study comes from consumer finance. Klarna's chief executive, Sebastian Siemiatkowski, told Bloomberg that the firm's automation push amounts to an imminent shock for knowledge work, not a distant prospect. In public interviews and in regulatory materials tied to its listing on the New York Stock Exchange, Klarna described an open AI-powered assistant that now performs work equivalent to hundreds of full-time agents, while the company curbed hiring and ran its headcount down from roughly 7,400 to about 3,000 through attrition.
In the future, there will be a digital financial assistant. It will analyze your spending, let's say your mortgage, and it will say like, that's too much. I found a better offer for you. The only thing you need to do is say yes, and I'll do all the paperwork and get it all done for you and save you the cost, right?
The company then listed in New York in September of 2025 at a valuation a little above $15 billion, underscoring that investors now price AI-enabled operating leverage into the core of retail finance. To understand how the labor market arrived here, the clock must rewind. In the 1980s and 1990s, personal computing and enterprise software diffused through white-collar offices. Economists at the Massachusetts Institute of Technology documented a task polarization pattern. Computers complemented abstract, non-routine cognitive work, substituted for routine cognitive and manual tasks, and left many non-routine manual jobs relatively untouched. The center of the labor market thinned as administrative and clerical roles became more automated or tradable, while employment shares grew at both the high and low ends of the wage distribution. That empirical picture, first formalized in studies of the 1990s, still frames today's debate. In the 2000s and early 2010s, globalization, broadband expansion, and cloud computing layered new channels for dispersing work. Offshoring and global supply chains amplified competitive pressure on routine tasks. Scholarly work from Brookings, and later updates by leading economists, argued that the net employment effect of automation was historically non-displacing at the aggregate level, even as labor's share of value added fell and distributional consequences grew sharper. The forces that pushed routine work toward software also pushed bargaining power toward capital-heavy firms, a trend now visible in platform economics and hyperscale data center models. The 2020s marked a structural break. Foundation models and cheap inference collapsed the marginal cost of prediction and drafting. The World Economic Forum's Future of Jobs assessment for 2025 aggregates employer plans across more than 1,000 companies representing over 14 million workers, and concludes that reconfiguration is broad-based, with new roles in AI, cybersecurity, and sustainability offset by reductions in administrative support and some customer service functions. The salient point is not a single disruptive technology, but the compounding effect of models, cloud, and data pipelines reorganizing how tasks are allocated within firms. The causal drivers are identifiable. First, compute economics have shifted. Hyperscalers and chip designers built an infrastructure stack capable of training and serving frontier models at industrial scale, enabling product teams to embed inference in document editing, code, and customer operations. Second, venture capital and corporate balance sheets funded rapid diffusion through partnerships, developer ecosystems, and acquisitions. Third, regulation moved unevenly, with privacy and copyright standards still coalescing, leaving managers to optimize for speed under uncertainty. Fourth, a decade-long shift towards skills-based hiring created channels to value AI fluency outside of formal degrees, accelerating organizational uptake. Across these factors, the center of gravity is the task, not the job. Firms decompose workflows, assign model assist where confidence is high, and reserve human judgment for exceptions or high-stakes steps. McKinsey's baseline frame remains useful. Automation lifts productivity and output, but requires large numbers of workers to switch occupations or acquire new skills as tasks reallocate. Empirical anchors now bracket the trend. The U.S. Bureau of Labor Statistics projects that total employment will rise by a little more than 5 million between 2024 and 2034, with healthcare and social assistance absorbing the largest share of growth, while many office support roles contract or grow slowly. The same projections show labor force participation continuing to drift lower over the long run because of aging, even as prime age participation remains historically high. The implication is straightforward. Overall jobs continue to grow, but composition and required skills evolve quickly, and mid-career retraining becomes a macroeconomic variable, not a human resources anecdote. Klarna's journey illustrates the firm-level mechanics. An AI assistant took on a workload comparable to hundreds of agents and helped compress cost per contact, while the company slowed hiring across support functions. The initial implementation produced customer experience trade-offs and forced a recalibration toward a hybrid human-in-the-loop model. The financial outcome, combined with an eventual New York listing and a valuation above $15 billion, signals what many boards see. Once an automation pipeline stabilizes, marginal gains persist. That calculus now informs contact centers, compliance reviews, claims adjudication, and software remediation across industries. The human consequences are uneven. High-skill workers whose tasks are complemented by models, data engineers, AI product managers, domain expert analysts see productivity premiums and wage gains where model assistance scales output. Routine-heavy white-collar roles, from basic reporting to entry-level customer support, face the most direct substitution pressure. Prime age participation remains near multi-decade highs, but the distribution of hours, tasks, and bargaining leverage shifts within occupations. Historical research on task polarization remains predictive. Non-routine cognitive work expands, routine roles compress, and low-wage, non-routine manual services remain demand-constrained but persistent. The dispersion is occupational and regional, mapping to clusters that combine data access, managerial capacity, and capital budgets to deploy models. Wages follow the same logic. Early evidence suggests premiums for AI complementary skills and declining degree requirements in some AI-related postings, as firms prioritize demonstrable proficiency over credentials. Surveys from the Organization for Economic Cooperation and Development indicate that workers and managers report performance gains and improved working conditions where AI is implemented with training and oversight, but they also express concern about job loss and surveillance. The risk is not a sudden collapse in employment. It is a steady redistribution of tasks that devalues experience in routine roles, while concentrating earnings in organizations that can capitalize on model-assisted workflows. Education systems adjust more slowly than product roadmaps. Computer science enrollments surged over the past decade, but demand is shifting inside the field, toward data engineering, systems for machine learning, human-computer interaction, and secure deployment of models at scale. Outside computer science, the binding constraint is not exposure to AI, but structured practice in data literacy, prompt design for domain tasks, statistical reasoning, and the governance of automated decisions. Employers increasingly signal this shift by emphasizing skills, taxonomies, and internal academies. LinkedIn's labor market analytics and independent hiring studies show rising use of terms like AI literacy and a measurable increase in postings that either require or prefer facility with model-assisted tools. The diffusion pattern mirrors the rollout of spreadsheets a generation ago, but with far wider task coverage. Regional dispersion will matter for policy. Metropolitan areas anchored by research universities, cloud infrastructure, and venture networks such as the Bay Area, Boston, New York, and Austin compound advantages as AI complementary roles cluster. Other regions with strong service sectors may experience slower wage growth in routine office work unless local employers invest in upskilling and hybrid workflows. Mapping data from university-industry collaborations already shows metropolitan concentration in AI-tagged postings. That concentration interacts with housing costs, commuting patterns, and in-office mandates to determine who participates in the gains. The near-term outlook is neither apocalyptic nor complacent. The World Economic Forum's 2025 report anticipates the creation of new roles across data, security, and sustainability, even as some administrative roles shrink. PricewaterhouseCoopers' global analysis of job ads and financials ties AI exposure to faster productivity growth at the firm level, suggesting that diffusion will raise output even where headcount remains flat. The US Bureau of Labor Statistics expects modest net job growth over the coming decade, concentrated in care and social assistance, while the composition of white-collar work changes internally as model-assisted tools become standard issue. Together, these anchors imply reallocation on a large scale, with productivity and earnings gains accruing to organizations that pair automation with redesign of workflows and training. Policy choices will mediate the distribution of gains. The evidence base from the task polarization literature is clear that technology's aggregate benefits can coexist with widening dispersion across education and regions. That makes portable benefits, faster credentialing, high-quality short-cycle training, and incentives for firms to invest in worker learning central to labor market resilience. It also makes measurement crucial. Public statistics should track tasks, not only occupations, to capture the speed at which workflows change inside the same job title. Employers will need governance frameworks that pair model deployment with auditing, bias testing, and clear escalation to human judgment in high-stakes contexts. Over the next decade, the pragmatic forecast is a labor market that grows slowly in net terms, but moves rapidly in its internal architecture. Customer operations, documentation, and entry-level analysis will absorb significant automation. Professional roles that specify problems, supervise models, and integrate outputs will expand. The difference between firms that substitute and firms that complement will show up in margins, retention, and wage ladders. The difference between regions that specialize in AI complementary ecosystems and regions that do not will show up in participation and household income. The clearest signals are already visible in company disclosures, labor market projections, and employer surveys. The adjustment path will be uneven, but the direction is stable. The era now unfolding asks institutions to treat reskilling and task redesign as core infrastructure, the way previous eras treated electrification and broadband. Adaptation will not be dramatic. It will be procedural, cumulative, and measurable, one workflow, one model-assisted task, and one retrained worker at a time.